On this second video, now we have everything powered up. We have the firing board with only the green LED showing that the board has power and it's enabled and it doesn't have a phase loss, so it's working under normal conditions. We have here the regulator, and the regulator board shows the 50 millivolt current feedback because we have a lamp load that is sized for 50 millivolt at maximum output. For our setup, we have 243 volts, 240 volts AC in, and we have 320 volts DC out. The board, right now, the way we have it all set up, if we were to monitor the status of it, it will tell us that it's in current limit. Here it will be hard to see the LEDs. And in this particular board, we set up differently. According to the customer, you have external IL, which is the current command, and external EL, voltage command. The way we have the board set, just for illustration purposes, we have 12 volts going to those two commands, and we're only going to control the board through the current limit and the voltage limit potentiometers, and we're going to induce current trips and voltage trips through the potentiometer. And under normal conditions, we have 240 volts DC, and what we have here is three signals. One looking at test point 5, which is the A phase reference on the firing board. We have here the delay angle of the firing board, and here we have the DC output across the lamp load. One of the things I want to do is I'm going to ask Tony to either decrease the voltage or the current. Let's do current, the current limit pot, and we'll see that as the DC output decreases, the delay angle changes. Notice that the delay angle right now, it's 13 degrees. It's between these two. So go ahead, Tony, can you decrease that? Go a little slow, Tony. As we see that as the DC output, it's decreasing, this line changes. So go ahead, Tony. So we notice that it's coming down, and this duty cycle of test point 3 on the firing board, it's out until the output disappears. At this point, Tony has maxed out on the potentiometer. The current feedback is no longer 50 millivolts. The AC input is still the same, but the output it's essentially zero. So Tony, we're going to stay here. Can you go and slowly work your way up? This is through the current. So now the feedback is starting to increase, and as it does, the voltage. And appreciate if you could stop at 50, 75 volts. Right, that's right there. That's good. 60 approximately. Hang on right there, Tony. Okay. So here we notice again, this phase reference will never change from the firing board. Test point 3 is the delay angle that is changing, and we can even see how one of these H's from the SCRs follows. One is for the A, the other one for the B, and the other one for the C phases. Again, the delay angle right now at this particular instance, it's 80 degrees. In other words, this is close to 50% duty cycle. And go ahead and bring it back again slowly, Tony, that current trip. So we notice the output again decreasing, the area under the curve. And we see that we follow that, and test point 5 never changes. Alright, we're going to do the same thing now with the voltage limit command. So Tony's going to decrease the voltage limit pot, and we're going to go through the same exercise. Normally, customers keep one of the settings as a threshold. In this particular case, the current limit for all Rowad cables, the current limit, and it's the voltage limit that provides the output. So we're looking here again that we have 244, the output is slowly coming down, and so is the 50 millivolt current feedback, which is a function of the load. So if we take a look here, it's basically the same effect. Go ahead, Tony, keep on going. You gotten it, you're our maximum, right? Now at this point, the current, it's keeping the limit, and that's why you cannot go all the way to zero. So let's go back and increase the value of that potentiometer or turn it clockwise, but essentially it's the same. Now you have the two potentiometers at the maximum, correct?
Yep.
All right. So now what I'm going to ask you to do is I'm going to ask you to instantly inhibit the board. Or well, actually, if you notice, we're not going to do that for this customer because this particular customer for the 6100 board has 4 and 6 tied together, so there's no need.
Yeah.
This means that the instant enable, it's always on. The board will always instantly enable. The instant function, it's defeated. The only control it's through the I2 knot, through the soft. So let's go ahead and we can see it here through the start and stop. So let's go ahead and enable, Tony. And hold on, before we do that, go ahead and inhibit. So we see the output came to 0, 245, and let's go ahead and enable again. Notice, this will be really hard to see, but here you don't see the difference between instantaneous and soft. Let's go ahead and take a look here in the scope. All right, go ahead, Tony, inhibit. Go ahead and enable. So we can see there the output, it's slowly ramping up. Go ahead, Tony, inhibit. So the delay angle changed to the maximum. Go ahead and enable. It's slowly coming up. All right. The last thing I want to show here is the current trip and a voltage trip. The way that we're going to fake it is we're going to take first one of the current trip or the voltage trip potentiometers, and we're going to bring it down until, in this particular case, a current trip. We're basically lowering the threshold out of a J2 or a little relay will be toggling, telling us that we have a current trip situation. And what it does here is bring it back again, Tony, till you clear that condition. Let me know when it's cleared.
Okay.
Is it clear now?
Yeah.
All right, so slowly come back until you get, there you go. So the board is trying to phase back. It's trying to clear that condition. It's reducing its output. It goes to 60, to 70, to 80, and it comes back to about 130. Let's go ahead and bring it back to a maximum, Tony. And let's do the same thing with voltage, please.
There you go.
And there it is again. So again, the voltage, we got in the threshold. The voltage is more than the voltage tripping threshold, so it's telling the board, gotta come back, gotta be reduced because it's going above the threshold. Again, this situation gets resolved once we increase the threshold. Let's come back again, Tony. In voltage. There you go. Just keep it right there, resetting, and let me show right here that we have now our voltage trip coming. So let's go ahead and bring it up, Tony, to a maximum, and then on the last part of the last video, we're going to show the feedback, and we're going to show how the output normally will ramp up. This is the end of the second video.